Hey there, my name is Hydrogen Heather, and we found out the moment that we were done shooting our Facebook Live that the video quality was absolutely absurdly horrible. So it turns out we had a techie glitch with our internet connection. So what we're gonna do is we're gonna reshoot the experiment and put it up on YouTube so that you can actually watch it and do it with your children. And the beauty of this experiment is in its simplicity to run while you're learning some very complex science facts. So let's just jump right in. For this experiment, all you need are a few glasses of water, and then you'll need some straws, a flashlight, but if you don't have a flashlight handy, the light that comes down from inside your house will work just fine, and then some dish soap. So we decided that we're not going to try to recreate the atmosphere where the girls don't know what question I'm going to ask. So I'm just going to step in where we were. When we are talking about the sun's light, I asked all of you, what color is the sun? And what did all of you say?
Yellow.
You said yellow. Oh, Daniel, good job. But then when I pressed you and I said the sun is actually not yellow, I made you come up with a different answer. And Nevaeh, what did you say?
Orange.
You said it was orange, but then I said, well, the sun is actually not orange, so I pressed again. And Olivia, if you can't choose yellow and you can't choose orange, where might you go next?
I said orange is yellow.
Yeah, you said orangish yellow, and I kind of agreed. When I go to my box of crayons or markers and I'm going to draw a sun, I'm either going to grab my yellow, my orange, or my red, and sometimes, like Olivia, I might even mix all three of them up if I'm coloring a sunset. But it turns out that the sun is not yellow, it's not orange, it's not red. Everybody tell me, what color is the sun?
White.
The sun is a star that emits a white hot light. And here's the deal, the never broken rule of light. Light is going to travel in straight lines unless something interferes with it or gets in its way. So that's what this experiment's all about. So let's begin with light traveling in straight lines. And I'm going to put a few glasses of water here. And then I'm going to give everybody a straw. Let's see, Daniel, you take the nice straight one. Nevaeh. Okay, and remember, go this way. Now, what I want all of you to do is take your straw, and I want you to dip it into the water like this, but then look at the straw through the water and tell me, do you see any kind of a change? Livia, what are you noticing?
It looks broken.
It does look broken, but did you break the straw on its way into its glass? No. So what's going on here is as the light from the ceiling, which is also white, is coming down and going through the water is interfering with those straight lines, and it creates the optical illusion of the straw being broken. And then I also notice when I'm looking at Daniel and Savannah's straws that they look much bigger. And if you've ever been in the pool and looked down at your feet and legs, they look huge. And it's because of the way that the light refracts or changes direction as it goes through the water. Okay, so I'm going to take these cups away. So that's experiment number one. Just find a nice clear glass of water, put something in it, and look at the optical illusion of what happens when the light is interfered with. And now what we're going to do is we're going to go back to that question about the sun's white light. So first of all, we need to discover this word called atmosphere. So if you have children who might not know exactly what the word atmosphere is, here's the best way to convey it. Everybody just take a big deep breath with me. Ready? Okay, the air that you just breathed surrounds the earth and it's called the atmosphere. Say it with me. Okay, so it turns out if you were on the moon, there's no atmosphere and you would not be able to do that. You could not breathe. You'd have to have a space helmet. So what we're going to do is we're going to create an atmosphere and we're going to see what happens when the sun's white light shines through the atmosphere. And to do that, I'm going to give everybody a small cup of water. I'm going to put a drop or two of just regular dish soap into everyone's cup. And now, I'd like you to watch what I do first before you actually do it, or Daniel's going to go right ahead of me. We're going to create an atmosphere that goes above our earth. So everyone go ahead and create an atmosphere for me. Okay, good. Now you can stop. That's perfect. Perfect. So I want you to imagine that this is the earth and this is our atmosphere. and I'm going to shine the light. And everybody tell me, what do you see on your atmosphere? So wait, I want to confirm. I'm shining a white light, but you are seeing the colors of your rainbow? Okay, that makes sense because it turns out that white is actually a combination of all of the colors on what we call the electromagnetic spectrum, and the visible parts that come out are the colors of the rainbow. All right, so does everyone see a rainbow right on your atmosphere?
Yeah.
Okay, and now that Combustion Kurt has turned the lights off, do you see that rainbow even more strongly?
Yes.
Okay, I do as well. So now let's just make a super atmosphere. I'm gonna put all of our cups together.
Oh no.
And we don't want this to spill out onto the table, but what we do want is let's just make an even bigger atmosphere.
I can make my
Oh my goodness. Okay, perfect.
Okay,
Now,
okay.
everybody remind me, what color is the sun?
White.
It's white. And so I'm going to pretend this is the sun. I'm going to shine the white light down.
Looks so cool.
And then you see that the white light scatters into all of the colors of the rainbow. That is the visible portion of the electromagnetic spectrum. So can we have the lights back on, please, Combustion Kurt? Thank you. All right, so now a little bit of real world relevance. I'm going to ask a very simple question, and if you saw the Facebook Live video, this is exactly the same answer that they gave me. Everybody tell me, what color is the ocean?
Blue.
All right, so are all of you telling me that ocean water is blue?
Yes.
Okay. I'm going to tell you that ocean water is no different than this. Now, look at this cup of water and tell me, what color is water?
Clear.
Water is clear. And if you've ever played in the ocean, which all of you have, when you scoop up a bucket of water, what color is it?
Clear.
It's clear. Ocean water is not blue at all, but what happens is as the sun's white light is shining down, the ocean water interferes with the way that that light is traveling, and what happens is it absorbs all of the colors of the rainbow except blue. Blue does not get absorbed by the ocean. It gets reflected back out and scattered back out. So the ocean water is not blue at all. It's just that the ocean is capturing and absorbing all of the other colors of the rainbow except blue. So I hope that you have enjoyed this little replay of our bubble atmosphere, and we will see you right here again for our next experiment.